Can you remember? When I was explaining, when we were finding the minors of the matrix to study the rank. Why we were getting the vector as 0? Because I took the element as 1, 2 and 3 and the other as 2, 4 and 6. What was happening? There was some combination. Yes, because there was some relation between these two vectors. That means the second row elements were the multiple of the first row elements. Isn't it?
Yes, ma'am.
So in that case, you were getting the determinant as 0. So one thing you can prove that if you are having a square matrix, then you can prove that the vectors are linearly independent or dependent when you get the determinant as 0. So this determinant is getting 0 means you are getting some relation between the elements of the vector and the other vectors. And they are linearly related. Why linear? Because you can combine these elements, like if you take these as a vector as suppose x1, x2, x1, x2 and x3. These are a set of vectors. Again, you are having x1 dash, x2 dash, x3 dash as a vector. So we can say that there will be a relation between these vectors. If you get some number, that number will be actually a scalar number that we can say. If you get the scalar number by which you can combine these together, these elements in the form, like if you take k1 x1 plus k2 x2 plus k3 x3 as 0. If you consider this first element, these elements can be either a row element or a column element. Okay, so over here when you get the, because they are linear, see degree is 1, that is why they are called linear. So if you have a linear combination of these elements and you are taking this in the form of equation, what you can see that you can write k1 x1 is equal to, if you bring this the other side, you will have minus of this term, remaining term. Okay, so what you can get x1 as this term divided by 1 by k. 1 by k1. So this will exist, this linear relationship will exist when this k1 has to be not equal to 0. Understood till here? So this relation will exist when this k1 is not equal to 0. So this is the condition, one condition that this is one form of checking. Okay, when you are having a square 3 by 3 matrix. This is one form of checking because this you are getting a 0 because they are related. This is related to this. From this concept, I'm coming over here. If there is a relation between here, what conclusion you can draw? So if there is a relation between here, you can write this in the form of equation as this. Now this proves that the relation will exist only when this is not equal to 0. This k1 is not equal to, so there is a property that if you have a set of vectors like x1, x2, x3 or a1, a2, a3, we can say that these set of vectors are linearly dependent if you can find some scalars. These scalars are called the k1, x1. That means you can combine these scalars with other element also. This is, you are combining this with this. You can combine this with k1, a1 plus k2, a2 plus k3, a3 and so on, and then find the value of k1, k2 and k3. So if you see that if at least one of these k1, k2 and k3 are not equal to 0, then we can say that the vectors are linearly dependent. So how you are getting? Because you are getting this as from the combination of this. In another way, you can say they will be linearly dependent when there is a relation between these vectors. Like this is one vector, there is a relation that this second vector is a 2-time multiple of this. That means this is a relation. In another way, if you move backward, you can say that the vectors will be linearly dependent if you have a determinant as 0. So this is for the equal order matrix, that is M by M matrix. Okay, it is a square matrix. Now what will be the case if it is not a square matrix? Again, we have studied that concept when we were doing the rank of the matrix. So what we were doing? Can anybody say? Just recall what we were doing when we were finding the rank of the matrix. We were applying some elementary row operation. Okay, we were applying some elementary row operation and getting some values in echelon form. So from there we can conclude that if the rank of the matrix is less than minimum of order of the matrix, then we can say that the vectors are linearly what? Linearly independent or dependent? Can you guess?
Dependent.
Yes, they are linearly dependent. So if you can get, because why we are getting this as linear? Because you can see that there will be some relation. That is why you are reaching to 0 value. Some rows are getting 0 value because there is some relation. Otherwise, you cannot, because you can get only 0 value in this flow when you apply some operation. See, when you take 2 times of this, what is happening? All these elements are becoming 0 in the second row. So this elements will become 0 only when there is some relation between the current row and some other other row elements. Got it? So this is again an alternative way by which we can check. So this is one way that we can find the value of K1, K2 and K3 from the given set of vector. And if we say that at least one of these K is not equal to 0, then we can say that they are linearly dependent. If all the K value is 0, then they are independent. Or here also, if you take the determinant, if the determinant is not equal to 0, then all the vectors are linearly dependent, because there will be no relation. That is why you are getting this as 0. And again, another way that you can say that if the rank of the matrix is equal to the order of the matrix, minimum of the order, then we can say that they are linearly dependent. If it is less, then they are linearly independent. Understood?
Can you explain once again?
Which part?
Actually, my network connection was, there was a problem with my network connection. So
Okay.
I didn't get it.
Okay, I'm repeating again. This is related to the previous problem that we were doing when we were finding the rank of the matrix. So we can understand that if you are given a matrix, and if you see that the determinant is 0, you can visually understand from this example. Determinant you will get 0 when there is some relation between a particular row element with another row element. Like over here, this is an example that this second row element is 2 times multiple of the first row element. That means there is some relation between this. So whenever there is a relation, it is obvious. When you do the simplification, the value becomes 0. Or if you do the row operation and take the 2 times, the second row is 2 times the first row, then you will get all the elements as 0. Okay, so in that case, you will get the determinant value is 0. So from here, you can draw a conclusion that the vectors, I am referring to the matrix, okay, not vector calculus. The vectors will be, the vectors are called the elements of the matrix. So the vectors will be linearly dependent when the determinant of the matrix, when it is a square matrix, when the determinant of the matrix is 0. Or we can say that the vectors are linearly dependent when there is a relation between the particular row element with the other row element. Okay. Now I was explaining this part. How can you prove that? There is another method that I was explaining. How can you prove that the vectors are linearly dependent? Now see, if there is a linear means what? You can express these, you can combine these elements in the form of equation by taking a scalar in linear form. See, k1 x1, this is a linear equation. There is no degree 2, so it is a linear equation. So k1 x1 plus k2 x2 plus k3 x3 is equal to 0. So this is a linear relation. Now from this you can get the value of x1 by taking this element the other side. So you have k1 x1 is equal to negative of this element. So you can get the value of x1 as 1 by k1 into this. So this value will exist only when k1 is not equal to 0. And this will exist when there is a relation. So from this concept also you can say that the vectors will be linearly independent. Sorry, when there is a linearly, will be linearly dependent. If you can find some scalars, these are called the scalar because it is a real number, only one number. So when there is a setup, when you can get a scalars whose at least one value should not be equal to 0. That means you have to solve the system of equation to get the value as a value of these unknowns, k1, k2 and k3 and these. So if you get the system of equation value where at least one of these values are not equal to 0, then we can say that the vectors are linearly dependent. Another way by which you can check, that is related to finding the rank of the matrix. If you can see that the rank of the matrix that you are getting is less than the minimum of the order of the matrix, m by n, if it is not a square matrix, okay, then we can say that the vectors are linearly dependent. Why? Because some elements in the row you will get as 0. When it is rank is less than this order, then there is a surety that there is some row element in the matrix which is 0. So you are getting the row element as 0 only when there is a relation of that particular row with other elements of the row, because you cannot get 0. Because 0 you are getting it by subtracting or multiplying or doing some operation on this to make this element 0. So that means there has to be some relation. Like if I put over here as 3. So can you get any particular relation through which you can make
then there, ma'am, you said if rank is less than minimum order of the matrix, then there is a relation.
Yes. Like See, when you do a
And there is a
recurrent
relation between what, ma'am?
these are particular elements of the row. Because when we are dealing with matrix, we are considering this row elements or column element, no? See, were you present in the yesterday's class?
No, ma'am. Actually, there is a NCC parade is going on, and I was unable to join the class yesterday.
Okay, you were unable to join, but I have explained this in the last class also. So you can, and when I was explaining today, you could not pick up.
Yes, ma'am.
You could not pick up what I was explaining just today?
Ma'am, a bit of it I got it. So some of I
तो
tried to
एग्जाम्पल
study
कर लेना
yesterday
क्योंकि
as well.
अगर सब कोई एब्सेंट रहेगा तो फिर हम बार-बार एक ही चीज को डिटेल में रिपीट करेंगे ना तो फिर आगे नहीं बढ़ पाएंगे, ठीक है?
Yes, ma'am, I got it.
तो मतलब असली में क्या है, रैंक जब हम लोग निकालते हैं तो रैंक का हम अलग अलग प्रोसेस बताए हैं कैसे निकालना, और ये भी हमने बताया है कि डोंट अप्लाई द माइनस टू फाइंड द रैंक. ओके, जैसे छोटा छोटा एक, क्योंकि दैट इज पॉसिबल ओनली व्हेन यू हैव अ स्मॉल मैट्रिक्स के लिए इजीली तुम माइनस निकाल के, माइनर एक्चुअली यू कैन अंडरस्टैंड द सब मैट्रिक्स ऑफ द गिवन मैट्रिक्स. सो इफ यू ब्रेक द मैट्रिक्स इनटू स्मॉलर मैट्रिक्स इट विल बी टाइम कंज्यूमिंग. So it is better that you apply the row transformation or you go for the determinant and then check the rank. If it is a small matrix.
I have learned the row transformation method. So will that be enough for one method is enough, or I have to study all three?
No. If whatever is in the syllabus, you have to follow all those methods because you may be specifically given a method to use. Okay. So whatever methods are there, you have to know all the methods. So this is the thing to find the vectors are linearly independent or dependent. So this process is easier. If you have a square matrix, then it is a easier method to find whether it is independent or dependent. Directly you take the determinant. And otherwise you can use this and you can use this also. So in this case, you have to find this, or visually also you can understand. Like if I give you a small vector, then looking at that also you can find the combination between the vectors. Like if I give you the vector like this, 1, 2, 3, and 2, 4, 6, and 7, 8, 9. Are these vectors linearly independent or dependent? Looking at this also you can understand if you can find a relation.
Dependent.
Yes, because looking at this only you can understand that this is 2 times of the previous elements, or you can be half of this also you can say. So this is also there, and since they are dependent, you can move backward also. Obviously, you will get determinant value as 0 if you move in that way. And this is also connected to getting the rank of the matrix. Obviously, the rank of the matrix, all these terms are connected to each other. Obviously, the rank of the matrix will be less than this. So you can use any process. Now let us come to the example. Okay, check whether these vectors are linearly independent or dependent. You can do it by taking the combination which I said and find the scalars, value of the scalars, or you can take the determinant, or you can find the rank. Looking at this problem, if you can guess, I think looking at the problem, you cannot guess. It is difficult to guess looking at the problem. Or you can apply some operation also in any way.
Independent.
How you are getting? Yes, you are right. How you are getting? Which process you have used?
Determinant वाला यूज करा.
अच्छा, determinant वाला यूज किया हो, ठीक है. अगर इसका डिटरमिनेंट वाला यूज नहीं कर रहे हो, अगर स्केलर्स निकाल के कर रहे हो, तब देखना कि k1 k2 का वैल्यू सब 0 आएगा. वो मेथड भी लगा के देखो.
Can you solve this one, ma'am, please?
Okay. Determinant one, the one who have done, you can post that solution and you are doing it by using a scalars. Like in order to prove that these vectors are linearly independent or dependent, we can take that there exists some scalars through which you can combine these given vectors. So you have k1 combining it with the first vector. Okay, if you write these as the matrix form.
And then you have to solve 3 equations. It will be a
K1 x1 plus, yes, you have to solve 3 equation. So you have this general expression that if the vectors are linearly independent or dependent, there will exist some scalar k1, k2, k3 such that k1 x1 plus k2 x2 plus k3 x3 is equal to 0. So this is the property where you have to find the unknowns k1, k2, k3. So x1, x2 and x3 are given to you. Okay, so you just, this is given, this is x1, this is x2, this is x3. Now you put these values, k1, x1 is 1, 1, 1, plus k2, 1, 2, 3, k3, 2, 3, 8 will be equal to 0. Now this element is equal to 0. This is becomes a null vector, okay? Because there are 3 components, you can take this as null vector 0, 0, 0, so that you can separate 3 equations. So you are having k1 plus k2 plus 2 times k3 is equal to 0. Now this becomes the vector 1 to 1 correspondence vector. So you will have k1 plus 2 times k2 plus 3 times k3 is equal to 0. Again k1.
Now, how does the
So
second equation comes in k1 plus k2 plus 2k3 equals to 0?
See this element, this element, this element. Again
Yes,
this
I
element.
got it.
This element, this element, just like vector addition part, like directly if you don't want, then you can do one thing, that put this scalar. Actually there is a property, if you have a scalar over here, if you have a vector over here, then you can put this scalar inside, so it becomes k1. I did it directly, k1, k1, k1. Actually they are
Yes,
two operations.
I got it.
Okay, fine. Okay, fine. So now you have 3 equations, 3 equations and 3 unknowns.
Ma'am, both given, all are coming 0.
Yes, all are coming 0.
Coming 0.
Yes, ma'am. All are
Yes.
0.
Yes. So what conclusion?
Independent.
Linearly dependent.
Yes. So this all are getting. Again, you apply the transformation and check. So you can understand yourself which process you can cleverly choose to prove it.
Ma'am, transformation.
ट्रांसफॉर्मेशन ज्यादा सही है.
लगाओ ट्रांसफॉर्मेशन लगाओ, देखो खुद ही समझ में आ जाएगा.
हम रैंक 3 है.
हाँ तो रैंक 3 है, तो रैंक 3 है, दैट इज इक्वल टू, अब क्या प्रूफ करना है?
तो मैम उसके n के इक्वल है, तो कोई भी वो नहीं
नंबर ऑफ कंपोनेंट्स के इक्वल है. हाँ, तो नंबर ऑफ कंपोनेंट्स जो है उसके इक्वल है. सो द रैंक ऑफ दिस मैट्रिक्स इज इक्वल टू द नंबर ऑफ एलिमेंट्स ऑफ द मैट्रिक्स, नंबर ऑफ कंपोनेंट्स ऑफ द मैट्रिक्स, और यू कैन से दैट ऑर्डर ऑफ द मैट्रिक्स. अगर इसको मैट्रिक्स फॉर्म में लिखोगे, ऑर्डर ना लिख के, क्योंकि एलिमेंट्स दिया है ना सेपरेट सेपरेट, सो दिस इज द फर्स्ट कंपोनेंट ऑफ द मैट्रिक्स, second, so you can say that which is equal to the number of component 3 of the in the vector, so they are linearly independent. अगर रैंक 2 आ जाता,
K1 method called में
क्या
K1 method में नेम क्या है इसका?
ये वाला मेथड का
इसमें
बाय टेकिंग लीनियर कॉम्बिनेशन, ये डेफिनेशन वाले प्रॉपर्टी से गया है. वो किताब में होगा कि by using the property that if the vectors are linearly independent, then they will exist a scalar, these are the scalars such that the combination this is equal to 0. अब हमको प्रूफ करना है, तो हमें k1 k2 निकाल के वो प्रॉपर्टी में जाना है. ठीक है. So you are getting rank as 3, which is equal to the number of elements in the matrix, that is order of the matrix. So you can say that the vectors are linearly independent. ठीक है, समझ में आया? अब ये वाला लेके जाना. हाँ. अच्छा, अगर वेक्टर्स डिपेंडेंट है तो उसका रिलेशन भी कैसे निकलेगा? एक एग्जांपल लो. यू हैव अ वेक्टर
Excuse me, ma'am.
Yes.
Ma'am, is diagonalization of matrix in syllabus?
No. सिलेबस है ना वहाँ पे देख लो.
हाँ मैम, like linear
उसी में
independence
ही
का
है.
doubt. ठीक है
उसी
मैम.
में ही है. Okay, now prove that there is the vectors are linearly independent or dependent. If there is dependent, then find the relation.
मैम इंडिपेंडेंट
इंडिपेंडेंट है मैम.
नहीं ठीक से करो.
डिपेंडेंट.
Do it carefully.
डिपेंडेंट में.
मैम
डिपेंडेंट.
Yes, dependent. अब dependent है तो उसका relation कैसे निकलेगा कोशिश करो, नहीं होगा तो फिर हम बताते हैं.
h1 plus h2 equals to h3.
x1 plus x2 is equal to x3, right है, लेकिन कैसे निकालें?
k1 plus k2 k1 k2 k3 का वैल्यू निकाल लो. सॉल्व.
अच्छा पोस्ट करो, सॉल्यूशन पोस्ट करो, देखते हैं.
I mean, x1, x2, x3 are vectors, right?
Yes, x1, x2 are vectors.
And there are four components, like in 4 dimensions.
So it is a three vectors. Actually, you can consider this as a matrix ka component. That is first row, second row, third row. Or you can consider it as a first column, second column, or third column. Anyway.
Okay, ma'am.
क्योंकि मैट्रिक्स का चैप्टर है ना, तो उसी के रिलेटेड है. Okay, the one who have got the relation, post the solution. Let me see.
Ma'am, by just simple observation, it is visible. Ma'am, by just simple observation, it is visible. Linearly dependent can be proved by rank, as rank is coming 2.
Yeah, rank is coming 2. You can prove.
And by simple observation, it's coming x1 plus x2 equals to x3.
हाँ, लेकिन सिंपल ऑब्जर्वेशन में आ रहा है, लेकिन वो ऑब्जर्वेशन को राइटिंग में दिखाना है.
Okay, ma'am.
है ना?
मैम k1 इक्वल टू k2 इक्वल टू माइनस k3 आ रहा है.
पोस्ट करो तो वैसे समझ में आएगा.
Ma'am, I have just posted the solution in chat.
ఇది సీదా ట్యాక్స్ యాదనే నకీదు ఉంటుందా ఇది స్థాయి मेरे कौन सा है आप तो उधर बैठा
Ma'am, I have posted the solution in chat.
Okay, let me see. ये डायरेक्ट ऐसे करके नहीं लिखे, पहले रिड्यूस ही कर लो अच्छे से, फिर रिलेशन का लिखना। यहाँ से कहाँ से आया? Yes, this is correct. फिर इसके बाद वाला yes, right. इसको ऐसे काटो मत। So the vectors over here, they are dependent. So this you can take it as K3 as common and then take the other elements and say that K3 is not equal to 0. So this inside element is 0. ठीक है, वैसे काटना नहीं।
Okay, ma'am.
समझ में आया हम जो बोले? Got it?
Yes,
You take K3, K3 as common, then you take it as K3 into x1 minus x2 plus x3 is equal to 0. Then you write, since K3 is not equal to 0, so the inside term is equal to 0 and you get the relation.
Okay.
Ma'am, we
Why
understood
K3?
this method, but we are unable to understand another method, ma'am, which you told.
Which method? Ranking?
According to ranking, ma'am.
Now you do ranking, then you will get the answer there. Ranking बनाओ, वहीं से ही निकल जाएगा। पहले रैंकिंग तक पहुंचो, उसको रिड्यूस करो एकलन फॉर्म में।
Ma'am, in this way we get a relation between row 1, row 2 and row 3, right? This K method. Ma'am, so that's it. That's what we have to do in this question. That
Yes.
establish a
If there
relation.
is dependent, then obviously there will be a relation.
Yes.
Ma'am, what you said about we don't have to cut that constant there.
Yes. Over here, what he has done, he has taken K3 into the other term which is there. See what he has done, he is subtracting, he is cancelling K3 from both sides. Means if you cancel this, means looking at this, you can say that K3 you are cancelling.
It's
but if you take it mathematically, then that is not the thing. So you have to take K3 into the remaining term inside. So now then after that you have to prove that since K3 is not equal to 0. So this term will be equal to 0. Why I am telling K3 is not equal to 0? Because from the theory itself, you can say that if they are dependent, then there will be at least one scalar which is not equal to 0. Isn't it? Because see, if K3 becomes 0, then K2 also becomes 0. And if K2 becomes 0, then K1 also becomes 0. Then what is happening? You are getting all K1, K2, K3 is equal to 0. Got the point?
Yes, ma'am.
So if all becomes 0, then you are getting the contradiction over here. Means what you are having over here, you are not getting that. So it has to be not equal to 0. Otherwise, this will become linearly independent. But the solution is dependent. So there is a clash between these two. So that is the thing.
Ma'am, rank is coming too.
So, ma'am,
So
if
rank is
all K1, K2, and K3 are 0, they are independent.
Yes. Now, the one who have got rank 2, you just post it. From there, you can get the relation. So rank is 2, but the number of components over here is 3. Okay, so that is why they are dependent.
Okay, ma'am. Ma'am, the number of components, each component contain 4 numbers, but according to like vector, ma'am, the 4th component implies. Remember, I cap, J cap, and K cap, it implies in vector form. So like the 4th form is.
What 4th form is?
Like suppose in X1 it contains 1, 1, and 1 and 3. So the 3 here is like it.
I can't get what you are saying. Can you reduce this further? Can you reduce this further? इसमें और पॉसिबल है और रिडक्शन होगा और 0 को लेके जाओ ट्रांसफॉर्मेशन लेके हाँ क्या है कुछ बोलना है हाँ कि एक क्लास सिनॉप्सिस और वही है सर बोले उसी को रखा हाँ सर वही अभी मिले थे तो वो बोले कि अभी मैंने हमको वो स्कैन कॉपी भेज देंगे ताकि उसी में हाँ तो वो चाहिए अभी जमा देना है अभी तो नहीं मैम तो ये पूछने के लिए आपको कॉल किए थे पूछने के लिए अच्छा तो वो उनको ही स्कैन करके भेजेंगे तो उनका सिग्नेचर हो जाएगा बस उन्हीं का बचा है बस वही है पूछना आपको मुझे कॉल पे पूछेगा फोन करेंगे मैसेज हाँ तो वो सब क्लास है हाँ दे देता हूँ ठीक है मैं वही पूछना बाकी और काम का क्या स्टेटस है ये है थोड़ा बहुत फिर बाद में डिस्कस कर लेंगे अभी खत्म हो जाएगा क्लास 10 मिनट ठीक है सेकेंड हाफ में हम कितने बजे आ 3:30 के बाद या उसके पहले 3 o'clock भी आ सकते 3:30 के बाद 3:30 के बाद ही आ सकते ठीक है आ जाते हैं क्या हो रहा है कुछ?
So in this we can use column transformation also. Transforming
Yes, you
columns.
can try. Yeah. See, you can apply this technique for the row transformation. This logic will come. So when you have a matrix, you can write it in the form of AX is equal to B. Over here, B is what? Zero component of the matrix. And these are the elements. And over here, you are having X1, X is X1, X2, X3. This is X, which is given to you. And these are the components of the matrix. So you can write it in, how can you arrange the element? You can arrange like this, 1, 2, 3. That means these vectors are column 1, 1, 3, 2. Okay, this is 1, 2, 3, 4, 2, 4, 2, 3, 4, 7 is equal to 0. Isn't it?
2, 3, 4, 7.
Yes.
This is, this is 2, 3, 4, 7. So when you are applying the operation, rank operation, you are applying to this element. Isn't it? जैसे अगर रो ट्रांसफॉर्मेशन कर रहे हो तो इसी में ही कर रहे हो, इसी में करने के बाद देखना यहाँ पे जो जीरो एलिमेंट जो बचेगा इसी के साथ साथ तुमको रिलेशन मिलेगा. क्या समझ में आया?
Yes, sir.
करो, देखो करके देखो, फिर हम बताते हैं. जैसे अगर इसमें करते हो रो 2 इज इक्वल टू रो 2 माइनस रो 1, क्योंकि यहाँ पे कुछ एलिमेंट जीरो हो जाएगा. अगर रो 3 यू कैन टेक इट एज रो 3 माइनस रो 2, और रो 1 भी ले सकते हो, इससे कोई फर्क नहीं पड़ता है. इफ यू टेक इट रो 2 and you can take it as row 4. Sorry, this is row 4. Row 4 will be equal to row 4 minus 3 times. You can take 3 times of first row भी ले सकते हो ताकि यहाँ पे नेगेटिव में ना आए. So 3 times of row 1.
Excuse me, ma'am.
Yes.
Ma'am, I just posted solution in chat. So after this, what we have to do?
Okay. यहाँ if you take this, the multiplication of this element is not easy to find out because this is x1, x2. There are no 4 components, no? So you cannot multiply like this into this. So you need to have 4 vectors. So you have to take this as reverse. Got the point what I'm saying?
Yes, ma'am.
क्योंकि यहाँ पे 3 वेक्टर है, तो multiplication of matrix will be possible only when the number of rows of this should be matching, the number of row elements should be matching with the column element of multiplication element. So this इसका उल्टा होना चाहिए, जैसे हमने यहाँ पे बताया है.
Yes, ma'am.
यहाँ पे है ना, वैसे ही करके करना आ जाएगा. क्या समझ में आ रहा है कि कंफ्यूजन हो रहा है?
आ रहा है.
ये आप इसको रो ट्रांसफॉर्मेशन से भी बता ही दीजिए.
अच्छा, इसको माइनस करो तुम, यहाँ पे इसको सब्ट्रैक्ट करो. And this is the null element, so these elements are, you can take it as 0, 0, 0. It is not an issue. हम जो ऑपरेशन लिखे उसको मल्टीप्लाई करिए करो. So you will have 1, 1, 2. Okay, this is x1, x2, x3, and this is 0, 0, 0. So when you are applying this operation, you are having this as 0, this is 1, this is 1. When you are taking, this is 0, this is 1, this is 1. Again, this you are taking as 3 times I'm taking so that you don't get negative terms. So this is 3, this is 1, and this is 3 to the 6, so this is 1. So if you do operation, okay, let us try what will happen if we do the operation. Let us just see what is happening if we do the operation over here also. यहाँ पे operation करने से that is not an issue, 0 ही होगा. So if you do the operation over here, you will have x2 minus x1. If you do this operation over here, okay, this there is no need of doing the operation because there is 3 component over here. Just to apply the ranking over here in the matrix, in this matrix. Now you are having this. Now these 2 elements are the same. Next, अगर करना चाहोगे, so this element will become 0. बाद में, so if you do the operation, row 3 will be row 3 minus row 1, row 2. Again, row 4 will be row 4 minus row 3. तो इसको करने से हमारा क्या आ रहा है? This becomes 0, 0. This becomes 0, 0. So from this, what you can get x1 plus 2 x2 plus 2 times x3 is equal to 0. और यहाँ से आ रहा है हमारा x2 plus x3 is equal to 0. तो यहाँ से कुछ मिल रहा है? यहाँ से हमारा आ रहा है x1 plus x2 plus 2 times x3 is equal to 0. and यहाँ से आ रहा है x2 plus x3 is equal to 0. तो यहाँ से कुछ एक रिलेशन मिल रहा है.
Yes, ma'am.
तो क्या रिलेशन आ रहा है?
x1 equal to x2 equal to minus x3.
x1 is equal to x2
equals minus x3.
ऐसे कैसे आ रहा है यहाँ पे? ये दोबारा कर.
So x1 equals to minus x3.
So we can transform one more time.
Yeah, if you want, you can transform one more time.
Then it will come directly x1 equal to minus x3 and x2 equal to minus x3.
Okay, that way also you can do. Okay, okay. We have reached over here now. See, based on this, what you will get. So over here you are having x2 is equal to minus x3. So you put the value over here.
x नहीं होगा ना हम, ये k1 k2 k3 होगा ना.
नहीं, हम वो मैट्रिक्स का रो ट्रांसफॉर्मेशन लेके चल रहे हैं, वो स्केलर का भी नहीं लिए हैं. चीज एक ही बन रहा है, समझ में आ रहे हो?
x1 equal to minus x3.
हाँ, तो यहाँ पे चीज एक ही बन रहा है, लेकिन यहाँ से देख रहे हैं ना कि अगर हम इसको रो ट्रांसफॉर्मेशन ले रहे हैं तो रिलेशनशिप निकालना मुश्किल हो रहा है. एक चीज ध्यान दो, यहाँ पे रिलेशनशिप निकालना फिर उतना ये नहीं हो रहा है, और यहाँ पे इसमें हमारा रो ट्रांसफॉर्मेशन जा रहा है. लेकिन अगर हम k1 k2 को लेके कर रहे हैं तो वो डायरेक्टली थ्योरी के हिसाब से हमारा रिलेशनशिप आ जा रहा है. सिंस वी आर टेकिंग, एक ही चीज हो रहा है. देखो, एक चीज पहले जो हम लोग किए थे निकालना, एंड दैट मैट्रिक्स एंड दिस मैट्रिक्स, इज देयर एनी डिफरेंस? The previous matrix that we were using for with taking a scalar combination k1 k2 k3, ये जो combination लिए थे, अभी जो हम लिए हैं, is there any difference? हाँ, कोई डिफरेंस नहीं है. ठीक है, तो यहाँ से जो हम अगर रो ट्रांसफॉर्मेशन लेके अगर हम रिलेशन निकालेंगे ना, तो रिलेशन निकालने का कोई मतलब नहीं होगा इस तरह से, क्योंकि हम हमारा टेबल एक ही आ रहा है. तो इट इज बेटर दैट यू फॉलो द थ्योरी k1 k2 and k3, तो वहां से रिलेशन, क्योंकि एक ही चीज आ रहा है यहाँ से. बट दिस ट्रांसफॉर्मेशन विल बी यूजफुल टू स्टडी वेदर दे आर इंडिपेंडेंट और नॉट इंडिपेंडेंट. गॉट द पॉइंट?
Yes, ma'am.
So the thing, whatever thing you are getting, the thing is the same. एक ही चीज आ रहा है, लेकिन अगर if you follow the theory, the theoretical part, the vectors will be linearly independent or dependent if there exists a scalar, and based on the value of the scalar we can prove whether it is independent or dependent. तो वो theoretical part से ये match कर रहा है, because if we take k1 k2 or k3 or we take x1 x2 x3, it is the same. But if we combine the matrix पढ़े हो ना, system of equation ax is equal to b form में, पढ़े हो 11-12 में?
Yes, yes, ma'am.
Whether there is a the system of equation is consistent and all. चलेंगे तो you are getting the same thing over here which is similar to the equation that you are getting to prove whether the vectors are linearly independent or not. तो यहाँ से अगर इस तरह से ranking करके करना है, I think it is better not to use this technique. ये just हम ऐसे conclusions for your so that you don't get the confusion. तो वो वाला टेक्निक मतलब नहीं यूज करके वो वाला सिस्टम ऑफ इक्वेशन ले लेना, k1 k2 करके प्रूव करना, ठीक है. दिस वे यू कैन प्रूव बाय यूजिंग द ट्रांसफॉर्मेशन ओनली व्हेन दे आर इंडिपेंडेंट और डिपेंडेंट, वो प्रूव कर सकते हैं, लेकिन रिलेशनशिप निकालने में यहाँ पे फिर मुश्किल हो जा रहा है.
So there is no obligation to use this while finding the relationship.
No, you will get. Actually देखो इक्वेशंस एक ही बन रहा है, जहाँ पे वो वाला भी इक्वेशन आ रहा था उसमें भी वही इक्वेशन बन रहा था, यहाँ पे भी वही आ रहा था, लेकिन यहाँ पे क्या आ रहा था, वहां पे हमारा एक स्केलर के टर्म में आ रहा था. क्या समझ में आ रहा है? यहाँ पे एक स्केल, यहाँ पे क्या हो रहा है, कंपोनेंट ऑफ वेक्टर के टर्म में आ रहा है. Got the point? Okay, one thing you can do, you can solve this. Okay, the same thing you can solve by taking x1, x2, and the same thing you solve by taking the scalars. जो थ्योरी है, तब दोनों में मैप में कंपेयर करना, वहां पे डिफिकल्टी क्या आ रहा है. समझे हम जो बोल रहे हैं?
And one more thing, ma'am, can you record tomorrow's lecture because I might not be able to.
No, recording is actually not allowed over here. Recording is not allowed.
Ma'am, in lab classes, there is the sir has recorded the class and.
No, over here we are not allowed to do the recording because we need a copyright. Anybody can take the recording and they can post it somewhere or anything. Any lectures. It is not recorded. It is recorded only when permission is needed. Got the point?
So,
like whenever we take any material from the book also, it is not that we will take that material and we can use it here and there. We need a permission from the publisher or that we are using this material. So here also recording is not permitted. So you be present in class. You try to be present in class. And there will be a tutorial section also you can discuss in your tutorial class. And the book is also loaded. Yeah. So book is loaded over there. You can follow the book. You can discuss with your friends what was covered in the class. And if you are not able to understand, you can discuss in your tutorial section. Okay. Now for the home task, you do one thing. The same problem you solve it by taking this system of equation, ax is equal to b form, and then do the ranking formula. And another, you take the scalars form. But the thing is the same. You will reach to the same thing, but you will reach to some conclusion. कि क्या लेने से better होगा. बनाना उसको फिर हम next class में discuss करते हैं. ठीक है?
Ma'am, will you give any assignment questions to practice for quiz?
Assignment questions are already there in the website. Tutorial sheets है वहाँ पे, website में देख लेना. और उसी tutorial sheets पे discussion होगा. हमने यहाँ पे separate post नहीं किया है because that is common. That is common for everyone. It is in the website.
Okay, ma'am.
And the
in
book is
download
also,
section.
that I don't know how you can view. I don't remember. Maybe you will get in the download section. I don't know. You just search in the department website over there also you will get. It is loaded. Because that tutorial sheet is common for everyone. Okay. So see one thing again, I'm moving over here. So over here what you can see, you will get the relation, this relation that you are getting. Again you are getting this relation. So from this relation, you can use it. You are getting it actually. See over here, you are having over here x2 is equal to, okay, let me just erase this. I think you don't have class now. Do you have class? So just in 1 minute, okay. So you are having, okay, just x2 is equal to minus x3. You are getting it. So you can assume this as some value. You can take x2 is equal to minus x3. And if you take this as value as suppose t, say, the simplest way that you can do. So what you will have x2 as t and x3 as minus t. And if you put this value over here, you are having x1 plus t and minus 2t is equal to 0. So over here you are having x1 will be equal to t. So what you are getting, you are having x1 as t, x2 as t and x3 as minus t, but you don't have any equation in which you can put these values.
Yes,
So
infinite.
can you? So you are not getting. So this process, by using this process, it is not. You are not able to get it for the relation between this. So it is better you use the scalars. Although you are getting the same calculation, you are doing the same calculation, but only with respect to the variables there is a issue. Because when we are starting with the scalar combination, we already have a equation like k1, x1, those equations. So if any of these equations you put the value, then you can get. Okay. So I have explained over here. So you try again at home. Okay, we will meet in the next class. Got the point what I am saying?
Yes, ma'am.
Because you are getting some value for x1, x2, but where you have to put that value, you don't know. But when you are starting with the linear combination, you have the value k1, x1 plus k2, x2 plus k3, x3 is equal to 0. So you have a set of equations. So you put these values in any set of equation, you can get. But obviously, how many unknowns are there? There are 2 equations and there are 3 unknowns. So it is difficult to find the equation. Okay. So this process is only suitable to find the whether it is independent or dependent, but it is difficult to find what is the relation. Okay, we will meet in the next class.
मैम क्विज के बारे में कुछ पता चला?
क्विज का अभी नहीं पता, वो कमेंट में पता चलेगा, ठीक है? तो अगर if you have a common group, do you have a common group of BTech engineering maths? Common group, WhatsApp group?
No, ma'am.
Okay. Because last time they have posted it so that everyone can understand when you are having. So we are not informed yet. Main coordinator will inform us. Okay. Okay, I'm leaving now.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.